just want to make sure I'm hitting record. I kind of hinted at this already, that we can't just give any fluid, right? Because there are different types of dehydration based on what's going on. So we have to kind of figure out which fluid, how much, that kind of stuff, all right? These PowerPoints do it a little backwards, but that's all right, we'll deal. All right, so osmosis. Everyone knows that osmosis, fluids will flow from an area of lower concentration of molecules to a higher concentration of molecules so that it can achieve equilibrium. Okay? So, let's see. If I have, let's say squares are molecules, okay? And this is a square. All right? So if fluid flows from an area of lower concentration of molecules, so if circles are water, okay? It's going to flow from an area of lower concentration of molecules to an area of higher concentration because it wants to do what? Create balance, right? So I have squares and circles. So even though this has only 2 squares and 2 circles, and this has 4 squares and now 4 circles, they're balanced because there is the same amount of squares and circles on this side, and there is the same amount of squares and circles on that side. That's osmosis. Does everyone understand that? Because that's going to help you with determining IV fluids. Okay? So it's always going to go, water flows to an area of higher or more molecules because it's trying to balance it out. Everyone good?
Yes.
All right. So there are crystalloids and colloids. Crystalloids are basically water or solution that can pass through a semi-permeable membrane. Colloids tend to have molecules that are too big. That's like your albumin. We are going to be focusing on, obviously, on crystalloids, okay? IV solutions tend to be your crystalloids. I have to really erase that. All right. So when we talk about an isotonic solution, so we're talking about IV fluids, okay? So when I talk about an isotonic solution, then I have the solutes in the cell equal the solutes in the solution. So the little red circles are solutes, water is in blue. So you can see I have 1, 2, 3, 4 solutes outside the cell, and I have 1, 2, 3, 4 solutes inside the cell. So is any water going to be moving in and out of the cell? No, because we have balance. We have homeostasis, okay? So we don't affect the intracellular fluid at all. So intracellular is here, inside this cell. Inside this circle is the intracellular, okay? So when I give this type of fluid, when I give an isotonic fluid, I'm not affecting the cell at all because osmosis isn't happening, right? All I'm going to be doing is expanding the extracellular fluid or the intravascular fluid. Does that make sense to everybody? Intravascular is inside the vessels, or extracellular is just outside the cell. Means the same thing. Okay. So it doesn't have any effect on the intracellular fluid. Nothing on the ICF. Because there's no osmosis happening. This is used when we have some kind of volume deficit because we want to quickly expand the intravascular volume. So, if I'm really hypotensive or really hypovolemic because I have a big GI loss, like diarrhea, I'm just losing fluids, okay? If I'm losing a bunch of fluid, I have a burn. Burns, you lose a massive amount of fluids. We're going to talk about that in test 2. But if I'm losing fluids, I need an isotonic solution because I need to expand the intravascular or extracellular, it's the same thing, fluid.
Yeah.
Does it say what? Hypotensive, yes.
Hypovolemia.
Hypovolemia. It's okay. By the end, you will have all my little things down.
So you say that's because you're losing fluid, right?
You're losing fluid. Because think about this. If I'm losing fluid, I'm losing all of this, right? It's all going away. So I don't need to worry about the cell being hydrated. The cell's hydrated. I need to just replace volume, okay? So I'm going to give an isotonic solution. An isotonic solution has an equal amount of solutes in water, okay? It's an equal amount that we're giving. So when I give it, I'm not pushing water in the cell, I'm not pushing water out of the cell, I'm just expanding my volume. You have to be careful though, because I can give too much volume. So you can give too much volume, but that's not why we don't do an IV. All right. Now, is the NCLEX going to ask you, if you give too much isotonic fluid, what could happen? Nope, that was a level 1 question, maybe a level 2. They're going to tell you that you have a patient who had, amputated his leg, had a large amount of blood loss. So they gave, so far he's received 2 liters of fluids. On exam, you note bilateral crackles. What are you going to do? Stop the fluid, because you know that crackles is a sign of fluid overload. Do you see how the questions start going around now? You got to figure that out. They want you to understand, or they want to know that you know that crackles is fluid overload, that because he's getting a lot of fluid for his amputation and his blood loss, blah, blah, blah. Okay? That's where they're going to go with it. So when you guys are studying together, I will hear you guys studying in the hallways and stuff, and you'll ask, what are the signs and symptoms of fluid overload? I challenge you to give scenarios to your thing and say, you have a patient with this, what do you think it is? Flip it on them. It will help you study better, help your thought process. Mm-hmm.
This might be a stupid question, but can you have blood loss and still have fluid overload from ice?
Yeah, because if you have blood loss and you give them too much, it's always about balance. If you lose this much blood, right? I'm doing it the wrong way. But if you lose too much, and you're trying to catch up with fluids, you can surpass the fluid loss and give them too much. Does that make sense? Does that make? But yes. Now, if you continue to bleed and you don't stop the blood loss, you won't, but that's why we need to find out the cause. Because if they're just bleeding, and you're not treating the bleed, then no, you can't really overload them because they're continuing to bleed. But in theory, what they're saying is that you have controlled the bleed, and now that the bleed is controlled, their volume was depleted, and you want to get it back up, you just don't want to overdo it. So examples are lactated ringer and normal saline. And normal saline is what? 0.9%, right? Sodium chloride. So 0.9% sodium chloride. And this is table 1617 on page 293 of Lewis. It will give you a list of the solutions. 293. Now, a lot of people get confused with D5W. All right? D5W is isotonic in the bag, but it is not isotonic in your body. All right? So, with D5W, that is dextrose, right? 5% dextrose in water. So, water is not an isotonic solution, right? Because saline is 0.9% of sodium and chloride in water. So water cannot be isotonic because it does not have any electrolytes to balance it, right? Water is just a bunch of this, okay? I can't balance that. So that's not isotonic. So 0.9% is isotonic. Anything less than that is going to be hypotonic, and anything more is hypertonic. Yeah.
So D5W is isotonic. So
In the bag.
in the bag. So I had a patient this weekend that I had to give only 200 of D5W for low sodium, and I didn't know how that was going to help the sodium level.
For sodium?
Yeah. 'Cause if it's isotonic,
Just D5W?
yeah.
Are you sure it wasn't like D5 normal saline? D5W, because D5W contains no sodium chloride. Now there is D5 normal saline or D5 half, that contains it, but I can't speak to that. I don't know. Okay. Yeah. So D5W is just 5% dextrose in water. It is isotonic in the bag, but once that, is there an answer?
I think it was saying it helps replace fluid loss due to the hyper. Do they have
So once it gets into the body eats up that dextrose, and then it just becomes water. So that then it ends up being a hypotonic solution. So a lot of people get that confused. The D5W is isotonic in the bag, but it is considered hypotonic in the body because as soon as it's given, the dextrose gets kind of used up, and so then all you're providing is free water.
Would we get a question and ask 3 different types of isotonic, or?
You will get questions that will say, like, what kind of fluid do you need to give? You need to know that it's an isotonic fluid. You may get asked what kind of fluid, and you'll say isotonic, or you may get asked what kind of fluid, and you'll have to know that LR is isotonic because they're going to give you LR and D5W and D10 and all that. You do have to know the types of fluids. Right? Because when you're in a hospital situation, are you going to say, my patient needs an isotonic fluid, and then just stand there? No. You're going to go, my patient needs normal saline, or my patient needs LR, right? So you do need to know. Now, there's lots of variations. You need to know the basics. And that's where that table on page 293 helps you.
What would dictate if you give light-treated ringers versus normal saline?
Not a lot. Depends on the hospital policies, procedures. Yeah.
Doesn't the LR have some extra stuff in like electrolytes?
It does, yeah. So it just depends on what, some attendings really like normal saline, some really like LR. With burns, they tend to do LR a lot because of the extra electrolytes. So it just, it just depends. That's when you become an experienced nurse. And not, no offense to any of y'all, but right now, like that is like you'll figure that out based on that. But right now, I would just focus on understanding what an isotonic solution is and when I give it. All right. All right. So don't write that part down. Hold on. All right. So a hypotonic solution, again, we're talking about IV fluids. There are less solutes than the cells. So there's more water than electrolytes. So if I'm giving a solution that has more water than electrolytes, okay, where is this water gonna go?
In the cells?
Into the cell, right? Because I'm back to this. I have more water than electrolytes, so I'm pushing water into the cell. Because I want to create that balance. So it pulls water into the cell. It also rehydrates. But you have to be careful because it can cause cerebral edema. It makes the cells swell. So just like I had a risk with my isotonic to fluid overload, I can basically cell overload, all right? Because I can then keep giving a solution where I just keep dumping water into a cell, making the cell expand and eventually what? Pops. Yeah.
So you would give a hypotonic solution to like a head injury? Like to-
Yeah. It depends, but yeah. And we're gonna talk about that in just a second. So let's first, let's first. But this, yeah, you'd be careful.
What does that say, fluid something?
Fluid/rehydrates.
Oh,
Remember, I wrote all of this too. My hand hurt just as bad as y'all's. So you have to be careful for like things like cerebral edema. Okay? And again, a question could be something like, your patient comes in, they are receiving maintenance fluids of half normal saline at 100 mLs per hour. Patient was alert and oriented ×3 on initial exam and now is presenting with confusion. What would be your first action? Right? Yeah. Stop the fluids, right? Because I'm causing cerebral edema. So that's one of my first signs and symptoms that something's going wrong. So again, we don't flat out say, like, hey, you're like swelling the brain. We're going to give you an assessment of that. And what do we need to do? So remember, 0.9% is isotonic. So anything less than that is going to be hypotonic, and anything more than that is going to be hypertonic. So half normal saline is lower, okay? Because it's half of it. So I'm hypotonic. That's why D5W is hypotonic, because it's just 0%, right? It has no sodium chloride in it, and that dextrose gets eaten up. I hate these markers. And then lastly, we have hypertonic solutions, where there are more electrolytes in the solution than water cells. So what's going to happen? Where's fluid coming from? What's happening? From the cell, right? So because fluid wants to balance it out, it's going to, when I start giving a hypertonic solution, I'm going to start pulling water from the cell. They're all used to treat, so when they're hyponatremic, this is typically what you would give as a hypertonic solution. So if their sodium was 120, then I would think that they would be getting this, not D5W. Huh? Oh. So it can be used to treat hypovolemia, but also hyponatremia. Hyponatremia, that's what you use hypertonic solutions for. Again, you have risk of fluid overload because so much fluid is coming out of the cell. So this one, you're just filling up the intravascular space. This one, you're also filling up the intravascular space because you keep pulling more water out of the cell, okay? So this one also, you want to listen to lung sounds and, watching blood pressures, looking at sodium levels to make sure that they aren't having fluid overload. And again, it's anything that is more is hyper, okay? So if I add anything to 0.9%, it's more. Or if I add anything to LR, it's more. So D10 is considered hypertonic because only 5% of that one's kind of confusing. So D10 is considered hypertonic because only about 5% of the glucose gets eaten up. So with D10, I end up with basically D5 in the body. Okay? That's why it's hypertonic for D10.
So if that was the case, would you take a glucose reading on that patient?
You could, yeah. D5 LR would be more, right? Because LR is my base. If I add anything to LR, I'm making it hypertonic. D5 normal saline. I started with normal saline and I added something to it, so it's hypertonic. 3% normal saline, that you have to be careful with. We rarely give 3% to kids, but. And this is, so half normal saline is 0.45. And then we're adding 5% dextrose. So we're still above the 9%. I know it gets confusing, but it's still hypertonic solution, okay? Because you're adding to it. All right. So now you're like, I got it. I know what these solutions are now. I can tell you what is a hypertonic, what is a hypotonic, what is an isotonic solution, and I know what they're doing to the cells. Now, when the freak do I give them? Okay? It's pretty easy. We do it by sodium level. This is page 693 in Juan. Isotonic is the most common. And we, again, use their sodium level. So if their sodium is normal, 130-ish to 150, that means that we're losing electrolytes and waters at the same time. So I don't have fluid shifting. I don't have osmosis happening. So I'm just losing fluid and I need to replace fluid. What just replaces fluid? What kind of solution? An isotonic solution, right? I have an isotonic dehydration based on the sodium of 130 to 150. So I'm replacing it with an isotonic solution. And my isotonic solutions are normal saline, LR. You guys are going to get gold stars. All right. So what are some things that cause it? Severe vomiting, diarrhea, profuse bleeding, we treat it with an isotonic. I gotta take my heels off. Alright. So, if I have a hypotonic dehydration, that means I have lost more electrolytes than water. If I have a hypotonic dehydration, then I have lost more electrolytes than water. I think of it, hypotonic means less, right? So I've lost electrolytes. This can happen from muscle damage, burns, malnutrition, mannitol. So I need to treat with a hypertonic solution, the opposite. Because what does a hypertonic solution do? It takes water out of the cells, right? So that it creates that balance. I have to do it opposite. So, give me an example of a hypertonic solution. D5.5, D10W, 3%, right? D5 normal saline, D5LR. We need those electrolytes, okay? So we need electrolytes. Because we have lost electrolytes. Then you have your hypertonic dehydration. So remember before we were talking about solutions and what solutions do. Now we're talking about dehydration and what kind of dehydration your patient has. This is the most dangerous. They're most at risk of having seizures. This is where you lose more water than electrolytes. So think about it. You've got, this on. All right. So, oh, it's okay, everybody. I'll put it back on. So, you've got fluid loss. You've got hypertonic, okay? You've got squares and circles, okay? So you've got an even amount. All right? So now I have a hypertonic dehydration. All right. So I have lost more water, okay? So I've lost my waters. All right? What's going to happen now to the cell? It's going to shrink because water is going to do what? Come out so that it can balance it. All right? So if water is coming out of that cell to balance it, what do I need to give? A hypotonic, right, solution. Because what is a hypotonic solution going to do? Yep. So it's gonna help pull that water back into the cell so that the cell doesn't shrivel up. Does that make sense? So just like opposite way, if I had the same thing, can you see? Oh, sometimes I draw and I'm not drawing where you can see. Just tell me. All right. If I have a hypotonic dehydration, I'm losing more electrolytes, right? So I'm getting rid of these. What's going to happen? Fluid is going to start going into the cell. So in order for me to balance, I have to give a hypertonic solution so that I create more molecules so water comes back out of the cell. Does that make sense? Is everyone getting it? All right, it's a little confusing, but. This happens like diabetes insipidus, which is just profuse urination. You're going to learn about it in level 4 when you get like head injuries. Diuretics cause it. But again, it's the opposite because you want to have. Oh, I'm doing it, and you see this. Y'all have to tell me. Is it back now? There you go. So it's the opposite. I know what it's doing, so I've got to do the opposite. Right? The only thing you have to be careful about is if they are not peeing, you have to be really careful, okay? Because if they're not peeing, what's happened to their potassium? It's going up. So make sure that if they are not peeing, that whatever solution you give them does not have potassium in it.
Is that hyperventilation?
Yes, hyperventilation. Profuse sweating. Diabetes insipidus. Diuretics. So everyone understands, I know what kind of IV fluids I have. I know the IV fluids. Give me some hypotonic solutions. D5W, half normal saline, okay? Because again, they're gonna give you a scenario and say, your patient came in with, has been on Lasix for whatever, long time. Or recently put on Lasix. That's probably more likely. Recently put on Lasix. Complains, clinical manifestations of blah, blah, blah. BNP shows a sodium of 155. What solution, or what's your next step? Call the doctor, put on whatever. One was maybe to start, start half normal saline. Okay. Sorry, I try to make up these things on the fly, and sometimes they don't work out well. But do you get the kind of idea of where they're going with it? All right. So you got to know your IV fluids. You got to know what type they are, whether they're isotonic, hypotonic, hypertonic, what they're doing, and then know the types of dehydration and how you would treat them. And again, I challenge you when you're questioning each other, don't just ask, what is the signs and symptoms of this? Give the signs and symptoms and see if your friend can figure it out. And you all like to really study what you know because it makes you feel really smart. I know. You'll be like, I keep studying the same thing because you're like, I got this. And then I'll ask you a question and you're like, don't ask me that, I don't know that, right? So, but that's how you figure out what you don't know when your friend challenges you and says, here's a scenario. You guys know that basically with hyponatremia or hypernatremia, it's more neurological symptoms, right? Twitching, jerking, neurological muscle. And then anything with potassium has to do with heart, cardiac dysrhythmias. Now, obviously, there's a whole list of things, but the big ones are potassium, cardiac. Sodium tends to be more neurological, muscle related. All right. So now you're like, awesome. I know all about IV solutions. I know how they work. I know about types of dehydration. And I know when to give what solution. And I know all that. But now, how do I know how much to give? That's your new math. Okay? It is really pretty darn easy. Of all the math, it's going to be pretty darn easy.
Is that the 24-hour thing?
It's the 24-hour maintenance. Okay? So, once you know, again, what to give, when to give it, why to give it, you need to know how much to give it. How much to give. So, for the first 10 kilograms, 0 to 10 kilograms, you're going to give 100 mLs per kilogram. For 11 to 20 kilograms, you're going to give, just skip this, 50 milligrams per kilogram. And anything greater than 20, you're going to give 20 mLs per kilo. So let's do this together. Don't, it's okay. Okay, so 0 to 10 kilograms equals 100 mLs per kilo. All right? 11 to 20 kilograms is 50 mLs per kilo. And greater than 20 is 20 mLs per kilogram. This is for 24 hours. Now, let's say I give you a 26 kilogram patient. What a lot of people mess up and do is they jump right to this. And they will do 26 times 20. You can't do that. All right? You always start from 0. So I know that if I have a 26 kilogram patient, I'm going to look at steps. So I would memorize this little step right here, and I would brain dump that onto your paper as soon as I got in there, okay, if you need it. So I'm going to start always with step 1. Think of these as steps. And as soon as I run out of kilograms, I've run out of steps. So I'm starting with step 1. So I'm going to take the first 10 kilograms. So I can minus 10 kilograms. I'm down to 16. And I'm going to take those first 10 kilograms times 100 mLs. And what am I going to get? 1,000. Right? So this is supposed to be over 1 ml, 1 kilogram. Does everyone see how I got that so far? All right. Well, I still have stuff left over. So I have to go to step 2 now. So step 2 tells me between 11 and 20, I have to get 50. So I'm using up another 10 kilograms, correct? So I'm still using up 10 kilograms times how much? 50 mLs. What am I getting? 500. But I still have kilograms left. So I still need to go to my next step. So my next step says that now, for those last 6 kilograms, I'm going to be doing what?
Times 20?
20. Okay? So what is that? 120 mLs. Okay?
So you add all those up?
So now I'm going to add all those up. And I get 2, 5, 6, 1,620 mLs. Okay? That's for how long?
24 hours.
That's for 24 hours. Now, what happens if I had done just 26 times 20?
It's too much.
Oh, Lord. 26 times 20 would have only given me 520 mLs. Okay? That's why you've always got to start at step 1. That's one mistake I'll see students start. They're like, oh, 26, anything greater than 20, I'm going to give just 20 per mLs per kilo. Nope, you always start with the first 10 kilos. All right? Or you're not going to give enough. They may say, they want to know what's your fluids per hour. So then you would do 1,620 divided by 24. And what does that give you? 67.5 mLs per hour, right? Can we give 67.5 mLs? So how are we going to round that? 68. You cannot give half a drop, okay? I know the little machines do it wonderfully for us, but back in the old day, before, like, when I worked, they didn't have machines. I would literally have to count my drops. I can't count half a drop, okay? So you have to figure out, it's gonna be 68 mLs an hour times 24 hours. That gives them their fluid maintenance, all right? Now, what if I started with, let's say, 14 kilograms? Where do I start? Okay, so tell me what to do. Okay, so I'm doing 10 times 100, right? So I'm 1,000. I have to minus my 10, right? Now what am I do? What's that? Do I have anything left?
No.
No? So I minus my 4, I'm down, I'm good. I add this, I have 1,200. Okay, that's my, for 24 hours, 1,200. Okay, if I want to do 1,200 divided by 24, what's that? 50? I'm trusting you because I don't know. So 50 per hour.
This is specific for pediatrics.
This is for everybody, this is adults. Yeah, most of the time, like when an adult comes in, I never do step 1 or 2 because you're going to, step 1, if they're greater than 10 kilos, will always be 1,000. Like you don't really have to do that math. If they're greater than 20 kilos, you're always going to have step 1 and step 2. So I always just start at 1,500 mLs and then I add the extra to that. But it's for adults and pediatrics. If you don't feel comfortable with that, just knowing off the top of your head, don't, just do it step by step to ensure that you do it right. What if I started with 6 kilos? I go to my step 1, that's 6 times 10, what is that? 600. Do I have step 2 or 3? No. So it's just 624 hours, which is how much per hour? Oh, I'm sorry. Thank you. I forgot my zeros. Okay, so 25 cc's an hour, or mLs per hour, I should say. All right. Does everyone get the math? That's it. That's the new math for this one. That is the easiest new math.
Hard.
It did. I thought
This,
it was
the
gonna-
way it's on the PowerPoint makes it look confusing. Yeah, that's like, I'm like, what the heck is this?
So, okay. Has everyone got that?
Yeah.
All right. Remember, there is math resources in your course. And the math resources have NIPS doing this example. Okay?
It's just.
The
Yep.
way you just showed us.
Yep. In addition, remember, not only will you get the new math, you will get math from level 1 and level 2. So when you go to test the course content and you go to exam 1, there are math resources. They have pediatric fluid maintenance. They have like 10 examples here for you with the answers worked out. So practice. Okay? In addition, there is a NIPS video with the worksheet. So practice. In addition, there is drip rate, which you will see on every test. So, oh, good job, guys. There is IV flow rate, which will be on every test. So, okay. There is math test 1 practice. So, practice, okay?
Word for the day?
Yes.
Are we able to get the answers though? for-
Yeah, I'll open them up for you. Because you asked nicely. There you go. All right. So, utilize your resources. The other thing to note is that a lot of times you guys don't read the question. You're doing the math right, but you miss like one little step. Note if it says 1,000 meter or milliliter bag, like a 1 liter bag, versus a 500, which is half of a liter. Okay. Note those differences, because a lot of times you get all the way through and you're like, that's how much in a liter. But we asked you for how much in 500 mLs. So you forgot to divide by 2 and you're like, freaker, okay? And you just lost 1 point because of something teeny tiny small, all right? So please look out for those things. All right, why don't I give you guys another little break, come back at 5.